Hey, it's Mr. Kingsbury. Welcome to the first video of the next semester. I don't know if that's going to be true in future years, but hey, why not? So our new unit now is about rational functions. Today we're going to be looking at the characteristics of those functions. And actually, this is the first video of two that we will be exploring those characteristics in. As always, this is my Algebra 2 class. I am Mr. Kingsbury. Don't forget to write down the period you have me and what date it is. Our question for the day is going to be, how can I find the important characteristics of a rational function if it's in transformation form? And that's important because rational functions, at least in our unit, are going to take two different forms. We need to be able to find some fairly important characteristics, whether we're looking at one of those forms or the other. Today, we're going to look at transformation form. So let's start by reviewing what does that look like. The transformation form of a rational function is this: y equals a over x minus c plus d. And I'm not sure why I put parentheses there, but I did. Don't forget that a is our vertical stretch. And technically, compression, for our purposes, we are not going to give you an a value that is a compression. It gets confusing. So for us, it's just going to be vertical stretch. Also, a is a reflection over the x-axis. Our c value is going to be whether we're moving left or right. And our d value will be whether we're moving up or down. So don't forget all those. A little brief reminder here. All right. What is important is, and I'm going to be doing a transformation video, so not sure why I wrote all that down. It's not really necessary. Well, I guess it's a good reminder. Anyway, I'll do a transformation video where we get into how to read these and write them and so forth. What's important is what else these things represent. When we're in class, we will look at the, what do you call that? We'll look at the parent function of the rational family there. And you're going to notice that there are some important things that we need to look at, including two new things called asymptotes. We'll be discussing those in class. An asymptote, A-S-Y-M-P-T-O-T-E. An asymptote is a line that a graph approaches, but never touches. I hope I spelled that right. T-O-U-C-H, yeah, E-S. I shouldn't doubt myself. Anyway, you'll see on the graph that there are asymptotes. You'll see that our graphs get closer and closer and closer to these lines. One will be vertical, one will be horizontal, and yet never actually touch them, never get there to that value or to that line. So it's kind of an interesting little thing that happens there. At any rate, we want to be able to identify those. We're also going to identify the domain, the range. In fact, let's write these things down. So we're going to be looking at asymptotes. There is something called a hole, but when the equation is in transformation form, there will be no holes for you to find. You won't be able to pick out. And when we talk about finding characteristics when it's not in transformation form, that will make more sense. So for today, we're going to limit it to this. We've got a horizontal asymptote. These are our characteristics. Horizontal asymptote, vertical asymptote. We definitely want to look at the y-intercept, the x-intercept, the domain, and the range. And actually, these tend to be very interconnected. So let me just see if I can't help you out here. Just a couple other things that we should add on here. This is really what I was leading up to. When it's in transformation form, A is really not going to be... Is it going to be that important? I don't know. Maybe. Probably not. But at any rate, the C and the D values are going to be important because the C value is going to give us our vertical asymptote. And our D value will give us the horizontal asymptote. And that's actually going to play into 4 of these 6 things here. So let me get you an example here and see if I can't walk you through it. Also, we'll graph our example. I think that's important, so we'll do that. So let me just give this to you. So y equals, let's just call it y equals 2 times x minus 5 plus 3. All right, and I'm going to graph that. So I'm graphing it off to the side where you can't see it. I'm very sorry for that. And of course, I just hit a wrong button, so it's going to take forever and a day. So 2 times x minus 2 divided by x minus 5, and then plus 3. And I just wanted to show you the graph of it. And actually, before I do that, let me just show you a graph of the parent function, so you have something to compare it to. So here is the parent function. It looks like this. The vertical asymptote is here. The horizontal asymptote is here. They're actually the axes right now. What happens is the C value and the D value, they move those asymptotes around. And we'll practice that in class. Right now, I just want to, we might practice some graphing in class. We'll see. Anyway, right now, I just wanted to point that out. And what happens is the asymptotes get moved around by the C and the D value, and then that allows us to name them. So now that I've done that, let me show you our function. All right. Yeah, did I turn it off? There we go. So here's the new one. You can see that there's a... It looks like there's a a horizontal asymptote here at value, it looks like about 3, y equals 3. And then the, what do you call that? The vertical asymptote looks like it's at about x equals 5. Let me just, sorry, I just wanted to look at something. Anyway, so how does that relate to what we go on here? Well, if you recall, I told you that the C value is the vertical asymptote. So my C value is 5, and my D value is, in this case, is 3. So how does that work? Well, if you'll note, there's a vertical asymptote at x equals 5. My C value is 5. It's the vertical asymptote. So I can write vertical asymptote at x equals 5. Similarly, the D value is 3, we said. And if you'll note, here at 3, 1, 2, 3, that is where our horizontal asymptote is. So horizontal asymptote at y equals 3. And I did y because it goes to the y-axis right here. So horizontal will always be y-axis, y equals, vertical will always be x equals. So there's that. That's 2 things right off the bat, which is kind of nice. And what's really great is they play into the domain and the range. The domain we're going to write, remember domain is all the x values. Well, this is a fraction. And the one restriction on the fraction is you can't have a 0 as your denominator. So right here, if I were to plug a 5 in here, 5 minus 5 would give me a 0. Well, that's not going to work. That's not going to be so good. So 5 is going to be the one value that my domain can't equal. Now, I know we've shown you some different ways to write domain in the past. You could write it in set notation or interval notation. There was one other one, or inequality notation. We're going to forego that this time and simplify it and simply say that the domain, we're just going to say what the domain can't be. So in this case, it just can't be the vertical asymptote. X is equal to 5, and we're just going to say it's not equal. So I want you to note this. The vertical asymptote is x equals 5. The domain is x is not equals to 5. They are identical except for this slash. And I bet a few of you are ahead of me. Yes, when I do the range, it is exactly the same thing. The range is all the possible y values. Well, it's going to be all real numbers except for this one y value where there's an asymptote. That's an undefined place. It's the one place where there's not any values. And that would be right here. So we're just going to say that y cannot equal 3. The rest of this you have seen before in one form or another. I need to find the x-intercept and the y-intercept. Well, to find the x-intercept, you plug in 0 for, to find the x-intercept, you plug 0 in for y. And to find the y-intercept, you plug 0 in for x. Not a big deal. Certainly you could also go to the calculator if you wanted to see if you could find it. I know that the y-intercept is there. If you go to the table, it would be, looks like it's 0 and 2.6. But I'm going to show you how to do it by hand. All right, so for the y-intercept, go ahead and plug 0 in for x. So y is going to equal 2. Here, I'll write it down and then I'll show you. Plug 0 in for x. And it's going to look like this. So y would equal 2 over 0 minus 5 plus 3. And that's honestly something you can put in the calculator if you wanted. 0 minus 5 is negative 5. So this is 2 over negative 5 plus 3. 2 over negative 5 is negative 0.4 plus 3. So y will equal will equal positive 2.6. I promise I can do math. So we will write that it is 0, 2.6. Similarly for the x-intercept, plug 0 in for y. Not a big deal. So when you do that, you get, and I'm kind of running out of paper here. This was not good planning on my part. So we plug 0 in for y. So 0 will equal 2 over, I really did not leave myself space. This was just not good planning. 0 equals 2 over x minus 5 plus 3. You would subtract 3 from both sides and get 3 equals 2 over x minus 5. And the next thing you would do is multiply both sides by x minus 5. The reason for that is it cancels out or simplifies out the division by x minus 5 over here. On this side, then, you can't even see what I'm doing because I'm not even on camera anymore. There we go. Sorry about this. Anyway, on the other side, you can distribute that 3. This is not organized well. So we got 3x minus 15 will equal, and then we got 2 on the other side. And then if you add 15 to both sides, oh, this is not pretty. 3x will equal 17, and then divide everything by 3. The 3's simplify out. So we get x equals 17 thirds. So 17 over 3 is 0. Yeah, that was not the prettiest one. Rational functions are often not pretty, by the way. And some of you may be asking about this being written as a decimal. Can I write it as a decimal? My suggestion to you would be no. Frequently when people write things as a decimal, they want to round them. And while that's all well and good, it loses accuracy when you round. So my suggestion is always, if your fraction can be simplified down to a decimal that ends, a terminating decimal, then write it as a decimal. Otherwise, leave it as a fraction. So that was ridiculously confusing and not at all well explained. So my apologies. Let's see if we can do a few more. All right, maybe I can organize this a little bit better. So let's go to the next page here and do maybe 2 more examples. And please keep in mind I am making these up on the spot, so they're probably not going to be pretty, but that's most of them. So do not worry if we don't get pretty answers. We're probably going to get a lot of fractions. All right, here we go, and we're back. Let's do example 2. I'm going to do 2 more examples. So here's example 2. Let's say I give you y equals 1 over x plus 3 minus 7. My C value is 7. My D value is negative 3. Nope, I got that wrong. My D value is negative 7. My C value will be negative 3. Remember, when the C value is in the equation, it always looks, or it always has the opposite sign of when it's not in the equation or the function. So we need to find the vertical asymptote. I'm going to just write VASYM, and the horizontal asymptote. We need to find the domain. The range. The x-intercept. And the y-intercept. Excellent. And I happen to know that, this is the way all intercepts are. They will be ordered pairs. For x, the y is always 0. For y, the x is always the opposite. So I can go ahead and put those in here, and then we can find some other stuff. These first 4 should fly by, all right? So C is negative 3. This is my vertical asymptote. My vertical asymptote will be x equals negative 3. And that means my domain will be x is not equal to negative 3. Straight from the C value. The D value is negative 7. That's my horizontal asymptote. That means y will be equal to negative 7 is my horizontal asymptote. Y is not equal to negative 7 is my range. Then I need to find the intercepts. That's always a little bit more fun. So for the x-intercept, I will plug 0 in for y. So 0 equals 1 over x plus 3 minus 7. I will add 7 to both sides. 7 equals 1 over x plus 3. Multiply both sides by x plus 3. And I'll distribute. 7 times x is 7x. 7 times 3 is 21. On this side, they simplify out, they cancel, and I get 1. I will subtract 21 from both sides, so 7x equals negative 20. That's genius. And then divide both sides by 7. So I get x equals negative 20 sevenths. So my x-intercept will be negative 20 sevenths over 0. For the y-intercept, I plug 0 in for x. This is more of an evaluating thing, which is nice. So y will equal 1 over 0 plus 3 minus 7. And 0 plus 3 is 3. So y equals 1 over 3 minus 7, which is 1/3 minus 7 is 20/3. Negative 20/3. So my y-intercept will be 0, comma, negative 20 over 3. Holy guacamole. That's crazy. Mostly what you will need to be doing on the test is writing an equation. If I give you this kind of stuff, you really won't be finding all of this. You'll be finding some of it. Anyway, let me give you another one, which is always fun. And let's see if I can't make this one pretty. So example 3, final example for the day. Y is equal to, I don't know, let's do x minus 2 on the bottom. That's always fun. 6 on the top, and let's do -1 like that. I think that should work nicely. Yeah, this will be a little bit prettier. So I saved the fun one for the end. My C value is going to be +2. My D value is going to be -1. And again, I know some of you are saying, Kingsbury, that's -2. You're right, it is -2. But remember, the C value in the equation always has the opposite sign of what it really is. So we're going to find the vertical asymptote, the horizontal asymptote, the domain, the range, the x-intercept, and the y-intercept, like so. So let's fill these in pretty quick. The vertical asymptote goes with C. It's going to be x equals 2, which means the domain will be x is not equal to 2. The horizontal asymptote goes with D. That's -1. So the horizontal asymptote will be y is equal to -1. The range will be y is not equal to -1. Let's find the x-intercept. We'll plug 0 in for y. So 0 will equal 6 over x minus 2 minus 1. We add 1 to both sides, so that 1 equals 6 over x minus 2. Multiply both sides by x minus 2. Distribute the 1, we get x minus 2 equals 6. Remember, on this side, the x minus 2's cancel. And if we add 2 to both sides, that means x equals 8. So our x-intercept will be 8, 0. And then for the y-intercept, we plug 0 in for x. So y will equal 6 over 0 minus 2 minus 1. 0 minus 2 is -2. So y will be 6 over -2 minus 1. 6 divided by -2 is -3. So I have y equals -3 minus 1, which is -4. So my y-intercept is 0, -4. See, that one was prettier. Anyway, there's just a little bit of an idea how to do that. I know it's probably a little bit confusing, and I apologize. I don't know that I explained it as well as I could. I do hope having 3 examples helps. I feel like once you do a few of these, you'll get the hang of them, and they will be much easier. Have a great day, and I'll see you in class.